Namaste. Okay, guys, I wanted to do a quick video on the answers to the frame of reference questions because I know these are a little bit more difficult for you guys. All right, as I was explaining to some of you guys, kind of on the side and stuff, when you guys were asking me questions about this. This is not a middle school concept. All right, this is really a high school type of concept. So it's something that, for the most part, I don't think any of you guys have been introduced to. All right, at least not in a scientific way. All right, so what I want to do is go over the answers to these. So here's number one. And, number one has a guy on a bus, and then the guy standing outside the bus. And for whatever reason, the guy standing outside the bus can actually see inside the bus. Let's just kind of go with that. Maybe the doors are, maybe the side is all glass, or maybe it's X-ray vision, or whoever, or whatever reason. But let's say you can see inside the bus. And so what happens is you have two frames of reference. You have this guy's frame of reference, which is the bus, inside the bus. And then you have that guy's frame of reference, which is outside the bus, which is mainly he's using the earth as his frame of reference. Now, if the bus takes off, and like when the bus takes off, all right, you kind of get this feeling like you're kind of pulled back in your seat when the bus is at rest, and then it moves forward. And what this guy would see, if he's inside the bus and he puts his ball on the floor, and then the bus takes off and moves this way, and if you imagine yourself inside the bus, you would see the ball moving towards the back of the bus. It would move away from you, okay, from your perspective, from your frame of reference, okay? But that's not what this guy sees. So this guy, whose frame of reference is the bus, sees the ball move away from him. This guy, and you have to ask yourself, what does he see moving? Well, this guy sees the bus moving, okay? So from his frame of reference, he's standing still, and the bus itself is what's doing the moving. So where this guy would see the ball roll back towards the back of the bus, this guy would see, if this was a point on the ground directly beneath the ball, this guy would see the ball kind of rolling in place as the bus rolled forward. So he wouldn't see the ball really moving. He would see the bus moving, and then the ball trying to stay in place. Okay, so which guy is correct? Well, according to Einstein, they both are. And according to Einstein, two things can be true at the same time, depending on your frame of reference. The universe works this way, and the universe allows two things to be true this way. Okay, so that's number one. Now let's take a look at number two. And in number two, we have two guys, and one guy's on the back of a pickup truck. So I'm going to draw, all right, a guy on the back of a pickup truck, and this is the crappiest pickup truck ever, but let's just go with it, okay? All right, and here he is, all right, he's back here, and he's going to chuck a rock, all right, and he's going to chuck a rock forward, whatever. Okay, and then you have this guy on the ground, like this, okay? And the pickup truck relative to this guy, now this guy's frame of reference is the pickup truck. The pickup truck is not moving relative to him. He's moving with the pickup truck. In the same way that you don't feel the earth is not moving to you because you're on the earth. You're moving with the earth. So if you use the earth as your frame of reference, you're not moving, you're just standing there. This guy's just standing on the back of the pickup truck. But this guy sees the pickup truck moving according to his frame of reference, and he sees the pickup truck moving at 10 miles per hour. Now, this guy on the pickup truck chucks the rock away from him at 10 miles an hour. And then the question is, how fast does this guy see the rock moving? Okay, well, in his frame of reference, the rock is already moving at 10 miles an hour because of the truck when it's being thrown. So this guy then throws the rock another 10 miles an hour relative to the truck forward. So how fast does this guy see the rock moving? Well, he would see the rock moving at 10 miles an hour to start with, and then given another 10 miles an hour by this guy. So he would see the rock moving at 20 miles per hour, okay, relative to him. So because he's already moving at 10, the rock is only moving 10 miles away from him, 10 miles per hour away from him, but it's moving 20 miles per hour forward relative to this guy. Okay? So who's right? Well, they both are, depending on which way you're looking at it, which frame of reference you have. Now, in question number 3, it's basically the same scenario, except now this guy over here chucks the rock backwards. Now, direction makes a difference, and that's why I had to teach you guys about, and I'm going to teach you guys about vectors and velocities, all right? Because sometimes, according to nature, direction makes a difference. So if this guy suddenly takes the rock and chucks it this way at 10 miles per hour away from him, what does this guy see? Well, this guy, if you take a look at it, what this guy sees is he sees the rock moving 10 miles an hour this way because of the truck, because it's on the truck. And then he sees this guy throw it this way at 10 miles per hour. And unlike the first scenario, where the two speeds were in the same direction, and this guy saw it at 20, and they added 10 and 10 make 20, this guy would see the 10 miles an hour this way being canceled by the 10 miles an hour that way. This guy would see the rock not moving. He'd see it at 0. There we go, that's better. So he would see it move at 0 miles per hour. Okay? So in other words, this guy who sees the whole truck moving with this guy on it and stuff like that would basically just see the rock drop straight down relative to him. That's a tougher one to get. A lot of people don't get that, but if you think about it, and you have to think about it, and remember that's one of the reasons why you're in a school, or at least a virtual school in this case, you're in school in order to prompt you to think, to learn, okay? And that's a hard thing for most people. That's why it's been said, thinking is hard. That's why most people don't really do it, okay? So, but if you do think about it, this guy has to see it that way. Now, this guy would see the ball go away from him at 10 miles an hour. He would see the ball kind of arc back and then fall, away from the truck somewhere behind it. This guy wouldn't. He would see the rock just kind of drop straight down and hit the ground, like right where the truck used to be, okay? So that's a tougher one. So think about that one a bit until you get it. And you might have to think about it until you get it. There's sometimes with these concepts, there's no magic way to explain it. You just, as a student, have to just kind of say, wait a second, what did Golas say? And then think about it until it eventually clicks inside you. And sometimes things are like that. Okay. Now the next question is the one with the stars. Okay, so this is a good question too. All right. So what you have is you have two stars and they're a light year apart. 1 light year, okay? And then you have this is point C over here, point A, and then point B, okay? And now C is literally, if you drew a line halfway between the stars and then extended it out to here, C would be the same distance away from each star. It would be the same distance away from this star as from this star, except just at an angle like that, okay? Now, that being the case, the observer at point C sees both of these stars explode at the same time, because he's also the same distance away from each star. Now, if you notice, the stars are a light year apart, and that you have to draw upon what you learned from astronomy. What does a light year mean? It's the distance that light travels in a year. It takes light a full year to travel 1 light year. So if you're at point A, and these two stars explode to this guy at the same time, what do you see at point A? Well, what you see is you see this star explode first, and then a full year later, you see this star explode. Why? Because from A's perspective, the light from here is starting a full light year further back. So the light, when this star explodes, the light from the explosion takes a full year just to get to there. And then it has to keep on traveling to A. So A sees this star explode first, and then this star explodes. So who's right? A or C? Well, according to Einstein, they both are. Why? Because they have different frames of reference, okay? Now, if you're an observer at point B, what do you see? Well, basically, you'd see the opposite of what A sees, okay? So where A sees this star explode first, and then a year later this one, B, who's closer to this star, would see this star explode first. And then a year later, it would see this star explode. It would see the opposite of what this person sees over there. Why? Same reason except in reverse. Because when they explode, the light from this star takes a full year just to get to this point, because it's a light year away. And then it has to keep on going to be, so this star's light is going to reach B first, and B will see this guy explode first, and then a year later, it'll see A explode. Okay, so, and again, who's right? They all are right. All three are, according to their frame of reference. Okay? All right, and the universe, again, works that way. All right? Okay, now the last one, I saw this video on YouTube, and I think I'm going to send it to you guys. All right, is, so what do you do? All right, I'll send you the video on it, but what happens is, so there's a truck. So here's some tow truck here, whatever, and this tow truck has a truck on it like this, and the truck is being towed, whatever, like that. Okay, pretend I'm actually drawing this in some coherent way. Okay, and so the truck is going this way. So what do? All right, so here you are in your car or your minivan or whatever, okay, and there you are, and you're driving along, whatever. Okay. And so what do you do to scare someone who's next to you, who's like sleeping or something like that? Well, you pull in behind this truck like that. Now, remember, both of you guys are on the highway and you're doing that sort of thing. You're moving, okay, like that. So what do? You speed up and you go towards this truck. And if they wake up suddenly, it'll look from their frame of reference, it'll look like this truck is moving towards them and is about to crash into you, okay? And that's how you do it. And I'm going to send you the video of that happening. There was some guy, this is an older video, someone posted this on YouTube like 10 years ago, but it's still pretty funny. Some husband, and he was driving in his car, and his wife was asleep next to him like that, and he wanted to spook her, he wanted to scare her, so what did he do? He saw this truck being towed in front of him, so he got in the same lane and he sped up like really fast, and he's like, "Hon, wake up!" And she wakes up, and all she sees is this from her perspective, this truck looking like it's coming towards her, and she freaks out. And that's a good way to get divorced. Okay, so I wouldn't recommend doing that, but it was kind of funny. So anyway, so those are the answers to questions 1 through 5 on the frame of reference. On the frame of reference questions. All right. See me with questions on this during office hours if after watching this video you still have some questions. So there you go. All right. Okay. Goal us out. Enjoy your apocalypse.